Hello everyone. So, have you ever looked up at a giant white windmills and wondered what it does? Well, those aren't actually a windmills anymore. They are a wind turbine and they are playing a super important role in order to keep our planet healthy. So today our group would like to present about a wind turbine. But before we start, let me introduce you to my group members. This group project consists of 7 members. First, our team leader, Muhammad Danish bin Abdul Halim. Second is Muhammad Kari Danish bin Hamzam, Muhammad Danish Haikal bin Azri, followed by Irdina Wajiha binti Khairul, Nur Ali Afifa binti Yaqub, Nur Aisha binti Ahmad Hanafi, and myself, Shazrina binti Sahari.
So first, let's start with the introduction of a wind turbine. What is a wind turbine? Wind turbine, or can be known as a wind turbine generator, is a device that converts the kinetic energy of wind, which is a natural and renewable source, into electricity. For your information, a wind turbine is the opposite of a fan, which is fan use electricity to make a wind, while wind turbine use wind to make electricity. For your information also, the turbine blades, which are like the propellers of an aeroplane and helicopter, use the aerodynamic force of the wind to turn a rotor, which spin a generator. This process produces electricity, which is usually fed into the grid. So next is the significance of a wind turbine. These are the significance of wind turbine that we found. Wind turbine can turn the power of wind into the electricity we all use to power our homes and businesses. They can be standalone, supplying just one or a very small number of homes or businesses, or they can be clustered to form part of a wind farm.
Hi everyone, my name is Nur Aisha binti Ahmad Hanafi, and today I will talk about scientific instrumentation and application concept of wind turbine. So as you can see, there is 8 components of scientific instrumentation, starting with anemometers, wind vanes, lidar, SCADA, yaw sensor, accelerometers and vibration sensor, temperature sensor, and lastly power meters. Let's discover it more detail. So firstly, anemometers. Anemometers help to determine the optimal location for wind turbine by providing the data on wind speed and direction. The second part is wind vanes. The purpose of wind vanes is to measure the wind detection. Next is lidar, aka light detection and ranging. It measures the wind speed and direction at various altitudes. The fourth item is SCADA. SCADA, known as Supervisory Control and Data Acquisition System. The function of SCADA is to ensure efficient operation, diagnose fault, and optimize maintenance schedule. Next part is yaw sensor. Yaw sensor detect orientation of turbine nacelle. Next is accelerometers and vibration sensor. Both of them detect the imbalance of fault in turbine component, preventing damage and reducing downtime. The next item is temperature sensor. The purpose of temperature sensor is to measure the temperature of critical components like generator or gearbox. And last but not least, power meters. Power meter will measure the electrical output of the turbine. So move to the next topic. The next topic is application concept of wind turbine. Wind turbine has a variety of applications, primarily focused to generating electricity from the wind energy. First, the application of wind turbine can be applied to utility-scale wind power. Utility-scale wind power involves the development of wind farm, for example, onshore or offshore wind farm. The onshore wind farm can be installed a multiple group of wind turbine to generate the electricity for the grid in a large scale. Next, this concept were applied to distribution generation like small wind turbine. Small wind turbine are installed at homes to produce electricity and reduce the electricity bills. Other than that, the community wind turbine are also being applied by the concept by own the wind project that provide electricity for the community. Other than that, community wind turbine are also being applied by this concept by own a wind project that provide electricity to the community. Lastly, hybrid system. This system are using this concept too. For instance, wind solar hybrid system. This system works by combining the wind turbine with a solar panel to provide more reliable and continuous power supply, as wind can complement to each other. Other than that, this concept can be applied to hybrid renewable energy. Wind turbine can be integrated with other sources like hydropower and biomass to enhance their energy.
Now, let's move to the detailed exploration of wind turbines. Wind turbines are a significant technology for generating renewable energy from wind. This process consists of several key components and technologies, each playing a crucial role in the effective production of energy. The first one is rotor blades. Wind energy is harnessed by the rotor blades of a wind turbine. These blades are designed similarly to airplane wings, creating lift when wind flows over them. Modern rotor blades are designed for aerodynamic efficiency and are often made from composite materials. These materials provide a combination of lightness and strength, enhancing the blade's performance and durability. The second one is foundation. Its purpose is to stabilize the turbine by anchoring it to the ground. These components' designs are dependent on soil characteristic and turbine size. For large turbines, deep concrete bases are frequently required. So now, let's move to the type of wind turbines. It is crucial to investigate the various types of wind turbines in order to have an understanding of them. There are several main types of wind turbines, which are utility scale wind turbine, offshore wind turbine, horizontal axis wind turbine, and vertical axis wind turbine. But the most basic type wind turbine is horizontal axis wind turbine and vertical axis wind turbine. The first one is horizontal axis wind turbine. Horizontal axis wind turbine are the most common type of wind turbine. The axis rotation is parallel to the ground. The blades are faced in the direction of wind and spin around a horizontal axis. Next is vertical axis wind turbine. The axis rotation is perpendicular to the ground. With the blades and shaft installed in this way, the turbine does not need to rotate to track wind direction.
I'm going to explain and elaborate more for example of real-world implementation. Firstly, for functionality, wind turbines operate on a simple principle. They capture the kinetic energy of the wind and convert it into mechanical power through the rotation of their blades. The blades are designed to be aerodynamic, allowing them to efficiently capture wind energy. They are typically made of fiberglass reinforced polyester or wind epoxy composites to withstand the stress of rotation. The rotation of the blades turns a shaft connected to a generator, which then produces electricity. This electricity can either be used immediately or stored in batteries for later use. Secondly, for locations, it have two types, which onshore and offshore wind turbines. For onshore wind turbines are the most common and are typically installed in areas with high and consistent wind speeds. These locations include plains, hills, and coastal regions. Offshore wind turbines are becoming increasingly popular due to the stronger and more consistent winds found at sea. Offshore wind farms are constructed in shallow waters close to the coastline or in deeper waters using floating platforms. The selection of suitable location for a wind farm involves wind resource assessment, environmental impact studies, and consideration of grid connection infrastructure.
So now we move to the next part, which the benefits and the challenge about the wind turbines. One of the primary benefits of using this wind turbine is renewable and sustainable. Wind is a renewable resource that is abundant and infinite resource, making wind turbines a reliable long-term energy solution. Unlike fossil fuels, which are finite and deplete over time, wind is continuously replenished, ensuring a consistent supply of energy. This makes wind turbine a reliable and sustainable long-term energy solution. They can provide electricity for countless generations without the risk of running out, contributing to a stable and enduring energy infrastructure that can support growing global energy demands. The renewable nature of wind energy also helps mitigate the environmental impact associated with conventional energy source, promoting a cleaner and more sustainable future. Next is good for the environment. When operating, wind energy emits no greenhouse gases such as carbon dioxide, methane, nitrous oxide, fluorinated gases, and for your information, all of these gases will increase the temperature of the Earth in the future for a long time. Next, we talk about the challenges. First is variable wind speed. It is inherently variable and dependent on the weather conditions. This variability means that wind turbines do not always produce electricity at a consistent rate. For example, during periods of low winds, the energy output can drop significantly, leading to potential gaps in the electricity supply. Second is a wildlife impact. It can endanger birds and bats, leading to fatalities due to collision with the blades. Here is the map of the United States. As we can see at the middle part of this map, which the purple color, it is where the wind reached the speed more than 7.5 meter per second. It reached the highest speed because the area are flat and facilitates for the movement of wind because have no obstacle. These areas are located in the North Dakota, South Dakota, Nebraska, Kansas, Oklahoma, and last one is Texas.
Now you must be wondered, in what ways will the wind turbine evolve in our daily life on the upcoming years? Let's have a look on the future development and innovation of wind turbine. Many scientists have come with thousand ideas to improve our wind turbine, but the most achievable and closest idea that we can get so far is floating wind turbine, which is a wind turbine that float on water. Just imagine the stronger and more consistent wind that we can get at the middle of the ocean. It will open up vast new area for wind farm development too. Floating turbine anchored by mooring lines can be placed in deeper water with stronger, consistent winds. Like the Hawaiian Skyline project, the world's first floating wind farm. This will allow wind farm development in previously inaccessible deep water areas. Projects like WindFloat Atlantic in Portugal demonstrate the potential to harness wind energy far from the coast. This innovation will expand potential areas for wind energy production, increasing renewable energy capacity. As for the developments, Siemens Gamesa Renewable Energy, a top wind turbine company in Spain, have been undergoing research and continue their efforts to enhance efficiency, reliability, and on improving floating turbine technology. Global testing of prototypes aims to optimize deployment and operation. For instance, Japan Fukushima Forward project is testing various floating wind turbine design to determine the most effective solution. Transitioning to commercial scale farms require refining design, reducing costs, and grid integration. The Kincardine offshore wind farm in Scotland is moving from a small scale prototypes to a larger operational scale, illustrating the development phase. Did you know there are many other innovation and development beyond our creativity to make this wind turbine better? For me, the most hilarious one is the bladeless wind turbine, which is you remove all the fan on the wind turbine and just make it like a pole. Okay, so for its like the traditional wind turbine, it uses large rotating blades attached to a rotor, and it converts kinetic energy from the wind into mechanical energy, then into electricity. But for the bladeless wind turbine, it utilizes a cylindrical structure that oscillates due to vortex shading, and it converts oscillatory motion into electrical energy system using an alternator system. But how? The vortex bladeless turbine harnesses wind through vortex shading around its cylindrical mass, creating alternating low pressure zone that induce side-to-side oscillation. This oscillation matches the turbine's natural frequency, enhancing efficiency through resonance. Mechanical oscillation inside the mass are converted into electrical energy via an alternator or linear generator. The turbine includes stability mechanism to control oscillation amplitude, ensuring optimal energy capture without structural damage. So the advantages of this bladeless wind power is to reduce noise and visual impact, quieter and less visually intrusive, suitable for urban and residential area. It also lower wildlife impact, which without the blade without the rotating blades, it reduces the risk to birds and bats for them to fly and suddenly impact with it. And the maintenance and durability, Fewer moving parts lead to lower maintenance need and potentially longer operational lifespan. And the cost effectiveness, which is simpler design, may result in lower manufacturing and
In a nutshell, wind turbines are a very powerful tools for generating clean energy. They harness the ever-present wind to create electricity with minimal environmental impact, reducing reliance on fossil fuels and air pollution. While consideration like wind consistency, wildlife impact, and land use need to be addressed too. The benefit of wind power are very undeniable. Wind turbines are a key players in a fight against climate change and the transition to make a sustainable future, making them a powerful tools in our future for a greener tomorrow. And this is our references. So that's all from us. Thank you for watching. #We love our planet.